For eons, the space between stars was thought to be a barren wasteland, a vacuum of nothingness separating the islands of light we call solar systems. But we were wrong. Emerging from the infinite darkness of the interstellar medium, a new traveler has been detected, moving with a velocity and trajectory that suggests it was born around a star we may never see. This is 3I/Atlas, the third interstellar object ever confirmed to enter our domain. Unlike the rocky, cigar-shaped Oumuamua or the more traditional-looking 2I Borisov, 3I/Atlas carries with it a distinct spectral signature that has baffled astronomers since its first light was captured by deep space surveys. It is a messenger from the deep, a remnant of a planetary birth that occurred millions of years ago in a corner of the Milky Way far removed from our own sun. As it plunges into the inner solar system, it accelerates under the increasing influence of our sun's gravity, yet it possesses too much kinetic energy to ever be captured. It is a visitor, not a resident, passing through our neighborhood at speeds that defy the orbital mechanics of our local comets. This historic approach marks a turning point in our ability to study the chemistry of other worlds without ever leaving our own orbit, providing a tangible link to the chemical evolution of the galaxy at large.
To understand the significance of 3I/Atlas, one must first look at its path. Most objects in our solar system, from the smallest asteroid to the largest planet, move in closed elliptical orbits, bound forever to the sun. 3I/Atlas is different. Its orbit is hyperbolic, boasting an eccentricity that places it firmly outside the gravitational family of our star. Coming in from a high northern galactic latitude, it avoided the gravitational perturbations of the outer gas giants, diving toward the sun with a purity of motion that allows scientists to backtrack its origin with incredible precision. Calculations suggest it has been traveling through the interstellar void for over 20 million years, having been ejected from its parent system during a period of intense planetary migration. As it nears its perihelion, the point closest to the sun, its velocity peaks, reaching a staggering 60 kilometers per second relative to the Earth. This high-speed flyby offers a very narrow window for observation, requiring a global coordination of telescopes. The angle of its approach is particularly fortuitous, as it passes near enough to the Earth for ground-based radar to bounce signals off its solid nucleus, potentially giving us the first high-resolution look at the surface of an object from another star system. This is a ballistic journey of cosmic proportions, and we are lucky enough to be standing in its way.
The heart of 3I/Atlas is a nucleus of ice and dust, but not like the ice we find in the Oort cloud. Early spectroscopic analysis from the James Webb Space Telescope has revealed an anomalous concentration of carbon monoxide and heavy isotopes that are rare in our neck of the woods. These chemical fingerprints suggest that 3I/Atlas formed in a much colder environment, perhaps on the outskirts of a red dwarf star or within a dense molecular cloud. As the comet warms under the sun's radiation, these ancient ices sublimate, turning directly from solid to gas and creating the magnificent tail, or coma, that makes it visible to our instruments. This outgassing process is violent and chaotic. Massive jets of vapor erupt from fissures in the crust, acting like small thrusters that subtly alter the comet's path. This non-gravitational acceleration is a key area of study, as it reveals the internal structure and porosity of the nucleus. Is it a solid block of ice, or a rubble pile held together by weak gravity? The density of 3I/Atlas appears to be lower than expected, hinting at a highly porous architecture that could be common among interstellar wanderers. By capturing the light reflected off these dust grains, we are essentially reading a fossil record of an alien solar system's formation, deciphering the recipe of a world that exists light years away. The scientific mobilization for 3I/Atlas is unprecedented. From the high-altitude deserts of Chile to the frozen peaks of Hawaii, every major observatory on the planet is synchronized to track this fleeting visitor. The Hubble Space Telescope provides high-resolution imaging of the inner coma, while the VLT, the Very Large Telescope, probes the chemical composition of the dust. This is a race against time. Because 3I/Atlas is moving so fast, every hour of observation counts. We are looking for signatures of organic molecules, the building blocks of life. If we find amino acids or complex hydrocarbons on 3I/Atlas, it would provide powerful evidence for the theory of lithopanspermia. the idea that the ingredients for life are distributed across the galaxy by comets and asteroids. This isn't just about rocks and ice, it's about the potential for biology to be a universal constant. The data being gathered right now will be analyzed for decades, forming the basis of our understanding of how unique or how common our own solar system's chemistry truly is. The world's greatest minds are focused on this single point of light, hoping to answer the fundamental question: are we made of the same stuff as the rest of the universe? As 3I/Atlas makes its closest approach to Earth, it becomes a spectacle for the naked eye. For a few brief weeks, this visitor from the stars graces our night sky, a ghostly green apparition trailing a tail millions of miles long. The green hue is caused by diatomic carbon and cyanogen being ionized by the solar wind, a common feature of comets, but strikingly vibrant in this interstellar guest. This close approach, passing within just 30 million miles of our planet, is a historic moment for humanity. For the first time, people across the globe can look up and see an object that does not belong to our sun. It serves as a profound reminder of our connection to the broader galaxy. Historically, comets were seen as omens, harbingers of change or disaster. Today, 3I/Atlas is seen as a harbinger of knowledge. It invites us to look beyond our planetary borders and contemplate the vastness of the space between the stars. The sight of it hanging in the twilight, silent and ancient, bridges the gap between the technical world of astrophysics and the timeless wonder of stargazing. It is a shared human experience, a brief window where we all look in the same direction, united by curiosity and the sheer beauty of a wandering star. One of the most fascinating aspects of 3I/Atlas is its interaction with our sun's magnetic environment. As the comet traverses the heliosphere, its tail reacts to the solar wind, a constant stream of charged particles flowing from the sun. Because 3I/Atlas is moving at an angle that cuts across these field lines, its tail exhibits unique kinks and disconnections, providing a natural laboratory for studying plasma physics. Scientists are particularly interested in the ion tail, which points directly away from the sun, and the dust tail, which curves along the comet's path. By observing how these tails behave, researchers can map the local conditions of the solar wind in regions that our probes rarely visit. Furthermore, the dust shed by 3I/Atlas will remain in our solar system long after the comet itself has departed. These microscopic grains of interstellar material will eventually settle into the plane of the planets, potentially even seeding our atmosphere with alien minerals during future meteor showers. This process of interstellar enrichment is a slow but steady way that galaxies exchange material, and 3I/Atlas is a primary contributor to this cosmic trade. We are literally witnessing the mixing of different star systems, a microscopic exchange that has massive implications for the long-term chemical evolution of our solar neighborhood. The arrival of 3I/ATLS has reinvigorated the debate over intercept missions. While we have visited many local comets, an interstellar object presents a much greater challenge due to its extreme speed. However, plans are already being drawn up for the next generation of comet interceptors. These would be spacecraft parked in a stable orbit around the sun, waiting for the next interstellar visitor to be detected. Once a target like 3I/ATLS is identified, the interceptor would deploy, using high-energy propulsion to match speeds and perform a close flyby or even a sample return. While we weren't ready to launch a mission for 3I/ATLS, the data we are gathering now is essential for designing the sensors and shielding these future probes will need. We need to know the hardness of the crust, the density of the coma, and the frequency of debris strikes. 3I/ATLS is essentially providing the blueprints for our first physical contact with an interstellar object. The dream of touching a piece of another star system is no longer science fiction. It is a technical goal that is moving closer to reality with every byte of data transmitted from our telescopes. We are learning how to catch a cosmic bullet, and 3I/ATLS is our most important practice target. The story of 3I/Atlas is also a story of human collaboration. In an era often defined by division, the pursuit of understanding this comet has brought together nations and institutions in a singular cause. Data is being shared in real time across borders, from the National Astronomical Observatory of Japan to the European Southern Observatory. This global network ensures that 3i Atlas is monitored 24 hours a day, never leaving our sight as the Earth rotates. Amateur astronomers have also played a crucial role, providing thousands of wide-field images that help track the comet's brightness and tail development. This citizen science aspect has democratized the discovery, allowing anyone with a telescope to contribute to our collective knowledge. The sheer volume of data is staggering, requiring advanced AI algorithms to sift through the noise and find the subtle signals of the comet's behavior. This synergy between human intuition and machine learning is defining a new era of astronomy. We are no longer limited by the perspective of a single lens. We are seeing the universe through a global eye, a collective consciousness focused on a single traveler from the stars. 3i Atlas has reminded us that when it comes to the mysteries of the universe, we are all on the same team, seeking the same truths. As quickly as it arrived, 3i/Atlas begins its inevitable departure. Having passed its point of closest approach, it is now slingshotting back out toward the edges of our solar system. The sun's heat begins to fade, the violent eruptions on its surface subside, and the magnificent tail starts to shrink. It will cross the orbit of Mars, then Jupiter, and eventually pass the Kuiper Belt, heading back into the frozen silence of the interstellar void. It will not return. Its path is a one-way street, a brief intersection with our history before it continues its journey across the galaxy for millions, perhaps billions of years. But it leaves us changed. We now have a clearer understanding of what lies out there. We have seen that the laws of chemistry and physics we observe here are the same laws that govern the furthest reaches of space. 3i/Atlas was a guest that stayed just long enough to tell us we are part of something much larger. It has broadened our horizons and sharpened our tools, preparing us for the next visitor that will inevitably emerge from the dark. The comet may be fading from our view, but the insights it provided are permanently etched into our scientific record, a legacy that will outlast the comet itself.
In the grand timeline of the universe, the visit of 3i/Atlas was less than a blink of an eye. Yet, for the brief moment it was here, it was the most important object in our sky. It reminded us of our vulnerability, our curiosity, and our capacity for wonder. As we look forward to the future, we do so with a renewed sense of purpose. We are building better telescopes, faster computers, and more ambitious spacecraft, all in the hope of catching the next messenger. Every interstellar object we study is a piece of a puzzle, a clue to how the galaxy was built and how life might be scattered among the stars. 3i/Atlas has now returned to the shadows, a silent wanderer once again, carrying our observations and our dreams with it into the deep. We watch it go with a sense of gratitude, for it has shown us that the universe is not a collection of isolated systems, but a vibrant, interconnected web of matter and energy. The voyage of 3i/Atlas may be ending for us, but for the comet, the journey is just beginning. And for humanity, the quest to understand our place among the stars continues, more fervent and more focused than ever before. Until the next visitor arrives, we keep our eyes on the horizon, waiting for the next spark in the dark.